This is the View Program Pre-Calculus course. We're doing topic 1, which is equations of lines. So no matter how many times you're asked the problem of finding the equation of a line, whether it's in Algebra 1 or Algebra 2 or Pre-Calc or Calculus or in a science class like physics, it really boils down to the same 3 steps. Find the point, find the slope, write the equation in point-slope form. The only reason to simplify an answer that's in point-slope form into some other form is if you are expressly asked to do so, or if doing so would make it easier for you to use the formula. Otherwise, if all you're asked to do is find the equation of a line, you should stop after point-slope form. So a couple quick reminders. First one is that point-slope form, through some slope, so you have some slope m, and you have some point, let's call it x1 comma y1. Right? Point slope form is y minus the y value equals m, x minus the x value. Right? So that's what we're talking about using here. So you'd find the slope, you'd find the point, and you write your answer in point slope form. And if you're asked to solve for y, but you're not expressly asked for slope intercept form, you can do the lazy thing of just adding that y1 over, which is super awesome and totally helpful. All right, so let's walk through some examples. We're going to do 4 examples here, and then you're going to do some practice problems. So example 1, we are going to do an equation of slope, or an equation of a line that passes through 2 points. So in 1a, so in all of these we are finding the equation of a line. In 1a we are given the 2 points 2, 3 and 4, 2. So recall that the way that we find slope is by doing y minus the y value. I'm going to go in this direction, and since I have a terrible memory, I draw a little arrow to indicate that. So 2 minus 3 over x minus the x value, which would be 4 minus 2. So I'm going to get a negative 1/2, right? So my answer then is going to be, I pick either point, it doesn't matter which one, I'm going to pick this one. Y minus the y value equals m, in parentheses, x minus the x value, and I'm done. And that's great, and that's my whole answer, right? If you had chosen to use the other point, the 4 and the 2, it would have been y minus 2 equals the negative 1/2 times the x minus 4 in parentheses. Great. For 1b, it's slightly harder because the 2 points I give you involve fractions, and I know how we love a fraction. Sorry, there's a dog sniffing around the computer, which is really helpful. All right, so again, I'm going to find my slope. It doesn't matter which direction you subtract. I'm going to go this way again. So I'm going to get a 1/3 minus a 2, which I'll deal with in a second. On the bottom, I'm going to get a 5 minus a 1/2. So I should make everybody in the top of the fraction into thirds. So this is a 1/3 minus a 6/3, right? And everybody on the bottom of the fraction should be in halves. So that's 10 halves minus 1/2. So I end up getting a negative 5/3 divided by a 9 halves. When we divide by a fraction, sorry, I'll inch you over there, we multiply by the reciprocal. So that's a negative 5/3 times a 2/9. So I'm going to get a negative 10 over 27. That's my slope. It's disgusting, but that's okay because my entire job is to write my answer in point slope. So I'm going to pick either point. I think the 1/2 and the 2 is slightly easier. So y minus the y value equals my negative 10/27, and then in parentheses, x minus the x value. Great. You can see why there's nothing happy about simplifying this. It's way easier to leave it like this. There's no advantage to putting things in slope-intercept form unless you are expressly asked to do so. If you didn't like this, you could have done it the other way with the y minus the 1/3, the negative 10/27, and then the x minus the 5. That would have also been a totally right answer that comes out to be exactly the same. All right, let's move on to example 2. In example 2, instead of being given 2 points, they actually do a bunch of the work for us. In example 2, we're asked to write the equation. So in example 2, we're asked to write the equation that has a slope of negative 1/5 and goes through the point 2, 6. So in example 2, you are actually handed the 2 pieces of information that I asked you to find. So boom, found them. Y minus the y value equals my m, which is the negative 1/5, x minus the x value. No incentive to clean it up. Done. Now let's talk about parallel and perpendicular because that's going to tie into my example 3 and 4 here, and also a little bit into example 5. So let's talk about parallel and perpendicular lines. So what it means to be parallel, if we think in the most basic sense of the word, is that lines have the same slope, okay? So they look like this. They never intersect. They're in the same plane. They never intersect because they have the same rise and the same run. A perfect example of this is the levels of a parking garage, right? If the levels of a parking garage intersect, you've got a problem because you just drove into the ceiling, right? You need them to be parallel. Perpendicular, meaning intersecting at 90-degree angles, right, means opposite reciprocal slopes, okay? So opposite reciprocal slopes. Now, For me personally, the way I think of this like a caveman is I think flip slope, change sign. That's what opposite reciprocal means. Change sign. And again, they intersect at 90-degree angles. So if I have two perpendicular lines, they make a 90-degree angle, right? Sorry, inching you over there. So the trick here is that both of these words are comparative adjectives, right? So a regular adjective is like the word good, right? You can be good. It's not comparing you to anything else. You're just good. But if I say the word better, that's a comparative adjective. That's comparing two things. I can be better than I was yesterday. I can be better than my cousin. I can be taller than my son. I can be smarter than a rock, right? But I can't be any of those things without comparing me to something else, right? So these are comparative adjectives. The reason that's relevant is that you can't be parallel to nothing, right? I can be parallel to the like the wall. I can be perpendicular to the floor, but I can't just be standing here all parallel, right? You have to be in relation to two things. So the reason that's relevant is that when you hear the word parallel or the word perpendicular in the problem you're handed, you are given two lines, and you have to be looking for both. So let's walk through this. In example 3, we're asked to find equations of parallel lines, right? So we want the line that is parallel, and we can use these like tall lines to indicate parallel. So 3a, right? 3a, we want parallel to the line y equals 3x minus 2, and we're asked to go through the point -5, 1. So what parallel tells me is same slope. So let's actually walk through this logically. We have this old line that we're given, y equals 3x minus 2, and that's parallel to some new line, and the only information that we know about the new line is that it goes through the point -5, 1, and that it's parallel to the old line. So the slope of the old line is 3, because this is already in slope-intercept form. I don't have to solve, it's already slope-intercept, and parallel means same slope. So using those pieces of information, I actually have the point and the slope for my new line, and my answer is going to be y minus the y value equals mx minus the x value, and that's my answer. No reason to simplify, right? Now we're going to do 3b, which is slightly harder than 3a. So again, example 3, we're still finding lines parallel. 3b, I want parallel to 4x plus 2y equals 7, and I want something through the line 10, 4. So again, it's helpful to realize that you're looking at two lines. The old line, which is 4x plus 2y equals 7, which is parallel to some new line, and that's the line you're looking for, right? And I know the point for the new line, right? 10, 4. So first thing I need to do here is identify the slope in the old line, because parallel means same slope, so I have to know what the slope is. So if I solve for y, I get a -4x plus 7 on this side. I divide everybody by 2. And the only part that's actually important is I get a -2 for the slope. I don't care that I get a 7/2 for the y-intercept, because this slope is all I care about. Parallel means same slope, so this line also must have a slope of -2. Now that I know a point and a slope, I can write my answer. Y minus the y value equals m in parentheses x minus the x value, and that is my parallel line. So example 4, you can imagine, is similar to example 3, except instead of the word parallel, now we're talking about perpendicular. So example 4. So in 4a, and actually I'm going to see if I can be slightly better about using my space here, and I'm going to try really hard not to have to erase the board every 5 seconds. So I have a line that is perpendicular, so I have this old line, okay? I have the old line. It is y equals 2x minus 8. And I want it to be perpendicular to some new line that goes through 6, 5, right? So this line has a slope of 2, or 2 over 1, right? But perpendicular means opposite reciprocal slope. So what that means, if you're thinking like a caveman, is flip slope, change sign, right? So flip the slope. Instead of 2 over 1, it's 1 over 2. And then change the sign. Since it was positive, it's now negative. So then my answer to my new line is y minus the y value equals my m, the -1/2, x minus the x value. And again, no reason to simplify that. If I come over here and try and squeeze in my 4b, it's the same concept, but just like we saw in example 3, this time I'm going to make you do a little bit of solving. So my old line in 4b is -3x plus 4y equals 10, and it's perpendicular to some new line that has the point 9, -2, right? So here we go. So the first thing I have to do is identify the original slope so that then I can do that whole flip slope change sign thing. So 4y equals 3x plus 10. I divide everybody by 4, and I'll be honest, I don't really care what happens over here. I just care that this thing has a slope of 3/4. Once I know this thing's slope, I know that perpendicular means flip slope change sign, so I get a new slope that is -4/3. And that's enough for me to get my answer, right? Y minus the y value, which will be y plus 2, equals -4/3, and then in parentheses, x minus 9. It's certainly never wrong to leave this as a y minus a -2, but it's just easier to call it y plus 2. All right, we're going to do one more example, and then you're going to do some practice problems. So example 5 involves a perpendicular line, but is a little bit trickier because the point is kind of secretly hidden for us. So in example 5, we're given this old line. We're given the old line, 2x minus 3y equals 10. And we're told that it's perpendicular to a new line. Great, so far, same exact problem. But we don't know the point. What we know is that it's the same x-intercept as the old line. They say that they intersect at the x-intercept. So now I actually need to do two things with this old line. I need to find its slope, and I need to find its x-intercept, because that's going to be my mystery point. So I'm going to go ahead and find the x-intercept first. X-intercept means that you plug in y equals 0. So that would be 2x minus 0 equals 10. 2x equals 10, x is 5. So first piece of information I have is that 5, 0 is the point. Great. Second piece of information I need to do is I now need to find that slope, right? So the slope of the old line is going to be -3y equals -2x plus 10. I divide everybody by -3, and I get that the old line has a slope of 2/3. But remember that perpendicular means flip slope change sign, so it must mean that my new slope is a -3/2. Well, here we are after a little bit of unconventional work with my slope and my point, so I write my answer as y minus the y value equals my m, which is -3/2, x minus the x value. And there's my answer. So you're going to do a couple practice problems. I think it's 1 through 8 in this section. They're very similar to these problems we just did. In fact, we just did essentially about that same number of problems, maybe exactly 8, even though you did 5 examples because of the A's and B's. So you're going to see that they mirror the problems you just did, and then we're going to go over them.